Well, hello, everyone. I'm Charles Sternbach, and it's a privilege to be here. I want to thank the organizing committee for the invitation to speak with you today. I want to congratulate Bob Webster and the organizing committee for the Dallas Geological Society Centenary. Centenaries are a wonderful thing, and APG just had one of its own. So if you look at the science that's driven our societies, there are key milestones, and I want to point out two Pratt conferences, one in 1984 and one in 2000, that produced AAPG memoirs, and I have studied these. How many here have the memoirs or have even attended the conferences? Please raise your hand. These conferences were wonderful, and when you look at them, the primary focus was looking to go to new areas, looking for new frontiers, looking for new horizons. What's amazing with the recent energy renaissance due to horizontal drilling and hydraulic fracturing and enhanced seismic imaging is that we are now looking back in the old basins more than ever before. So it's a paradigm shift. So in previous milestones of our science, people looked forward to future places. Now we continue to look forward to new places, but we also have tools that we didn't have to revitalize these old provinces with infrastructure. And so one of the programs I've worked very diligently on in 2018, 2019, and are working towards yet another third conference in 2020, are Superbasins. And I think of this collection as contributing to what may yet be classified as a third Platt conference. So let's look at a map of the largest superbasins around the world. There are probably 132 superbasins that meet the definition, which is 5 billion barrels equivalent produced, 5 billion barrels yet to produce, multiple pays and plays, and extensive infrastructure. And we're just looking at the top 25 or 30 here, because if you follow the 80-20 rule, these basins have a very major impact on the petroleum. So let's have a conversation today about the geoscience understanding of these basins, and more importantly, what can we learn from studying these basins that we can apply to other basins, and that we can take best practices and insights and be creative explorers. And one of the things that I've been fortunate to be involved with is the APG Giant Fields Initiative. So many of you know that there are about 1,000 giant fields in the world, giant field being 500 million barrel oil equivalent, and there are about 1,000 petroleum-bearing basins. We're just looking at the top 25 to 30 petroleum basins, and if you look at where the giant fields are, they are disproportionately, almost 60% of the giant fields are in the top petroleum basins. And there are some reasons for this. Excellent petroleum systems, the basins have the right geologic fundamentals. They also have infrastructure that enables the developing and the technology of the giant fields. And one of the things, if you study giant fields, you can see observations like in the Middle East by trap type, that there are structural giant fields in green. So where are the stratigraphic traps? We know they must exist because every major basin of the world has a mixture. So this is an area that's very underrepresented with stratigraphic traps when you study this. And there's going to be a conference, a GTW, APG is putting on about stratigraphic traps in the Middle East. It'll be next year. Also, California looks like it has a lot of structural traps, seems to be missing strat traps. And I know several people who have made recent discoveries in strat traps. So underrepresentation, when you study these things, leads you to future insights. So in the recent memoir, 113 of the giant fields of the decade 2000-2010, for the first time ever in this series of 5 giant fields memoirs, we introduced significant unconventional reservoirs like the Marcellus, like the Eagle Ford, and like the Bakken. This is a new wave of giants that are happening. And if you look at the trend of giant discoveries from 1968 to relatively recent, there was a golden age population, and we're now seeing in these last 2 decades a revitalized uptick in giant fields discoveries. And the 2020 decade's not done yet, and we're seeing regularly across the newswire additional discoveries being made. So I think that this is a good time to be finding giant fields. And so I like to use this quote by Herbert Harold Reed from Imperial College. And it applies, I believe, to why we should study giant fields in global basins. Simply, I suggest that the best geologist has seen the most rocks. And by looking at as many giant fields and as many of the world's largest basins, we can gain anticipatory insights. So to quickly review, there has been a lot of effort and technology developed in a fertile crescent of North America in the U.S. and Canada and North America that is really beginning these unconventional basins to take hold around the world. We'll look at some examples today from some of the far-off places. One of the first places outside of North America is Argentina in the Vaca Muerta play in the Neoquin Basin. And there are many other possibilities in Africa, Europe, China, and we don't have good stats here for Russia, but we know they exist. So let's look at a type locality superbasin. So here is the Midland Basin on the east, the Delaware Basin on the west, one big bowl-shaped basin which has a prominent uplift in the center basin platform. And what makes this basin great is it's got big, powerful source rocks deep into the basin, a big, thick package of sedimentary infill, and a regional seal that kind of keeps the bowl in. And then, I used to say if you have a map and a cross-section, you could get pretty far explaining any geological concept. And I've recently added that a map, a cross-section, and a event history, because that adds the 4th dimension to the 3 dimensions. And so if you look at the event history, this is a basin that has gotten charged early in its history, that has maintained very little disturbance to allow the hydrocarbons to escape the basin, and has a late tilt in the west from the Laramide, which creates, we'll hear some more from Bob Trentum about the residual oil zone. And it's interesting because when you look at these types of curves for all of the world's greatest basins, there are a few that have, like the North Sea, that have late tilts. So what we learn about the residual oil zone has global application. So let's look at the Argentinian Basin, the one I mentioned that is the next outstep from North America, and it is establishing commercial success. There's a mountain range, and what I'm told is that the 3 major source rocks are stacked, and so there's more than just the Vaca Muerta play, but there's several stacked shale plays. And I'm told that this is like Midland, except with mountains in the distance. So happen to have the Andes. So what I'm looking forward to is that the ICE convention in August to go on a field trip to stand in the middle of this basin. And you can see the cross-section and seismic here. It's got a really beautiful cliniform infilling basin. And of course, the toe sets are where the main production is coming out of. So that seems to be where the target landing zones are, down in the toe sets. And this is a very seismogenic play. Just for fun, let's look at a upscale of the U.S. Permian Basin in western Siberia. And this has got very simple architecture. If you look at the scale, let's look at the scale first. So here is the Permian Basin of the U.S. for scale. And so let me toggle back and forth to emphasize the profound size differential. You can see here many, many times over. And it extends not just onshore, but it extends out into the South Kara Sea, where some recent new giant fields are being. So it goes from onshore to offshore, both oil and gas. And the elements of the basin are very simple as well. Key source rocks deep in the section, migration through a very thick reservoir package, a bowl-shaped basin with some structural deformation, and a significant regional seal on the top that basically traps it in. So let's look at some of the fold and thrust belts. The Appalachians and the Marcellus is a good example. And what we learn here from folks like Bill Zagorski at Range Resources is that in the highly disturbed mountainous area, the shales have a lot of natural fracturing and calcite-filled fracturing. Where they're getting the best results are not in the highly disturbed areas on the seismic, but in the more flat-lying areas away from the mountain front range, where basically there's little or no shale fractures, and that the only fractures are those that are created by the hydraulic stimulation. That's the observation of what some of the key elements there. And if we look at the Western Canada Sedimentary Basin, this has got the mountain range on the left. You can see that there is a great migration, if you will, Paul McKay likes to say, of the source rocks from multiple source rocks trying to get from high pressure out to the low pressure. And when it successfully does so, you get oil sands at the surface. But for the most part, the most prolific places are in overpressured areas where the hydrocarbons are still trying to escape. Now, one of the things about the superbasins that I think is really exciting is to try to take lessons from one basin that might apply to other basins to jump up the learning curve. So here's a great example from Chris Cheatwood and Alfredo Guzman in an SPE paper. So using the Sprayberry and looking at the depositional model of the Sprayberry with the distal fan deposits and the lenticular sands, you can compare the Chicontepec Basin to the south. And so here's the Chicontepec Basin, which has a few wells in the center of it, but a lot of areas that haven't been drilled yet. And by well control and by seismic character, lots of lenticular sand bodies, different age, similar depositional model, different age. It's Paleocene, Eocene, where it's Permian in the Midland Basin. But the phenomenal difference is that the total number of wells in the Permian Basin are greater than 500,000, whereas in the Tampico-Mazantla Basin, it's less than 3,000. So I'm very interested what progress and what potential is yet to hear, because these are tight reservoirs just like the Sprayberry. And so the new technology, I want to commend the authors because they've pointed out the potential, great potential to be realized. So I also want to show some offshore. We look at the Gulf of Mexico. It's one of the greatest superbasins. It's 260 billion barrels oil equivalent. It's really a composite of several very large basins. And has three main source rocks, also low in the section. It has, the generation is continuing at present. There is a repetition of the oil window by salt naps. We'll talk about that, and strong vertical migration. So this is more of a leaky basin because of the active faults that are reaching the surface and the continual jostling, as pointed out by Tom Ewing. But nonetheless, it's a profoundly prolific basin. And if you look at this schematic cross-section, also from Tom Ewing, you note that you can go from the onshore plays with salt, and then the offshore subsalt play. So this is an area that has had a major rejuvenation by enhanced seismic imaging to see things that have never been seen before. And one thing I think is very interesting is that we know that salt is very transmissive to heat, so that you can see that the oil window out here, where people might have thought that this would be much more cooked and much more gassy, actually it's cooler because of the transmissibility of the heat from the salt. And so actually it has a very big impact that it's more prevalent to oil. So if you look now at Brazil and Campos basins in offshore Brazil, a series of wonderful discoveries in the subsalt beneath the evaporitic section. The prior history of the basin was producing from structures up and traps up in this upper level, but this whole hidden province has been revealed by the enhanced seismic imaging. And because of the enhanced seismic imaging, you can see that in recent times, the production has just taken off in both the Campos and even more so in the Santos. So just a boom in renaissance in old basins. And one of the things is that I've recently heard there's some deeper offshore basins that are subsalt. And I heard someone say there was concern whether they would be cooked for gas, whether they would be getting hotter because they're going down dip from oil basins, but they're subsalt. And keeping the Gulf of Mexico model in mind, I'd like to offer that one might surmise that subsalt, it might be possible to pursue the oil window or a repetition of the oil window farther to the east, which would be a very wonderful thing for yet a whole nother new series of outboard discoveries. So what are the keys to revitalizing these basins? Well, it's integrating geoscience with engineering. And here's an example from Pioneer showing the history of the Sprayberry play. It should be familiar to everyone here. The enhancing the stimulations, deepening the stimulations, going horizontal, and then stacking horizontals, and then adding greater length and stages. Geophysics, enhancing the geophysics enables subsalt. And I recently attended the APG Hedberg conference. It was really great. There were 187 people in a program in Houston. I don't know if anybody attended it, but really powerful. 50 years of major geochemistry, what it brings to our industry. And it plays a very significant role in identifying what are the key horizons, what are the distributions of the horizons, what are the timing and quality and types of the oils. So let's talk a little about landing zones and commercial efficiency. As we look at the various unconventional plays, this is a slide from Scott Sheffield, 2018. You see that what sets the Delaware and Midland is just the thickness of the pay. And in each of these other plays, they're thinner pays, and the refinements are critical in making a success. So let's look at the Bakken, and this is a great story because in the early Bakken, the first horizontal drilling was in the highest organic matter of the shale, and the play was a failure. It wasn't producing economic rates. And through time, it was realized that the more brittle siltstone separating the highest organic layers was the target zone. And what became a realization as these clinophores filmed in the basin and all of these different tow sets is that depending where you are in this intracratonic basin, you would get different benches that would be your target. And so isopacking these internal units using cores and 1-foot contours, as Orion Skinner explained in his outstanding AAPG Explorer talk at Discovery Thinking. They were able to identify sub-landing zones, sub-basinal landing zones that drove the play. Another thing I picked up at the Hedberg conference was what geochemists call vagrant gases. So if you're in a very mature basin and you have geochemistry, you often find source rocks that are different or deeper, indications of these source rocks, than your main producing source rock. And this has major potential. So let's talk about it a little bit. So we know that in the Permian, there's a lot of excitement about the Wolfcamp, and on the edges of the basin, there's excitement about the Woodford. But in the center of the Permian Basin, there's also Woodford and Simpson source rocks, and they have a geochemical signature. And the question is whether they will, at some point, be an interesting play to pursue. North Africa, and including the Middle East, has a deeper, it has Mesozoic source rocks, but has deeper Silurian source rocks and potential for shale gas, for example, in Algeria, significant out of a deeper source rock. North Sea is, of course, the Kimmeridgian main source rock, but there have been recognitions lately of possible new development in this basin from deeper source rocks. And so I think that this is a topic where geochemists can help us out. Now, one of the really big things about a superbasin and its economic viability is the ability to get product to market. So, for example, one of the great challenges is the Marcellus is one of the greatest gas fields in the world. And the markets are across the Appalachian Mountains. And so the challenge is to get this gas to market. And that is a big challenge. And the Permian is building its pipelines. And the key to value innovation is that you have to enhance the product and lower delivery costs. So if you look at these pipelines on land, the question is, wouldn't it be great to get all this connected up through the ocean? And of course, that's what LNG does and is becoming a major game changer for places like East Africa, for places in Northwest Australia, for the Haynesville in the U.S., and for other places around the world. It makes a global market for natural gas. And the number of tankers and vessels are going up daily. So this is a major game changer. We also want to say a word or two about big data, because in these superbasins, big data, superbasins have super data. Big basins have big data and big opportunities, as my friend Shandell Sable likes to say at Anadarko. There's intense well data sets, the ability to correlate petrophysical attributes of these well data sets, enhanced seismic imaging of various seismic data sets, and economic models that can be driven or derived from all of this data. And we'll hear about that in this conference. A lot to be done here with big data in big basins. So I'd like to talk about energy, environment, and economics, as our good friend Stott Tinker likes to talk about. All of this recent energy renaissance has major impacts, not just on our energy choices, on our energy security, but also on our environment and economics. So, if you look at the rise in production, the U.S. is on track to be 12 million barrels a day by the end of 2019. And one of the things is we are seeing increases. This is only current to 2015. This is this little bolt here. So this goes up yet again. But we're seeing increases in gas and decreases in coal. So that is a good thing for the environment. We'll talk about that. And one of the things I think is important not to forget is that in the energy equation, efficiency, there's a lot of new technology that's developing efficiency. And I've recently participated in a panel where we talk about electrification. And it's important for us as geoscientists to remind people that electricity comes from somewhere. It either comes from coal or increasingly natural gas, or it comes from nuclear or wind or water, but it has to come from somewhere. So I always find the debate about electric cars transforming our future. I've had people think that, well, you just plug in the cars. You just plug it in. That's where you get the electricity from. They're not thinking about how you create this electricity. And so all of the estimates on economics for electricity need to take into account the generation of the electricity. And swapping the coal for natural gas, you can see the effect that that's having on CO2 emissions. So the United States has actually done a very good job recently in reducing CO2 emissions simply because we are producing more natural gas and substituting it for coal. And then other places in the world, not so much. They're actually using a lot of coal, and they're some of the big polluters. And I like a diagram like this because it shows that we're now able to use a smaller footprint. And so underground, there's a drilling pad that's able to reach more of the subsurface. And of course, one of the alternative sources of energy is to use wind energy, which has a fairly large above ground footprint. But all is valuable and all is contributory to solving our energy needs. And the economics are huge. So I highly recommend, if you're interested, to get the America's Unconventional Energy Opportunity. Just Google it, a competitive advantage. It shows what the economic impacts of U.S. unconventionals have done for our economy. And this is a few years old now, and it just continues to grow. But you can see the benefits include contribution to GDP of $1,400 per capita because of energy, millions of jobs supported by the energy industry. When we toured the range resources facilities, a lot of young people with high-paying jobs walking around with hard hats and clipboards that didn't exist before. High-paying jobs, benefit to households of low-cost natural gas. You can see here on this chart, U.S. has got very cheap gas compared to South Korea or Switzerland, and here's Germany. They have 3 times the natural gas costs that we have. And then, of course, there's a federal tax revenue contribution, so that contributes from the revenues generated. So let's take a global view. This is another paradigm shift taken 50 years ago, a little over 50 years ago. The Earth from the moon. Let's look at the Earth at night over a 20-year period, a little over 20 years. And you can see that there's large areas of darkness. But as we toggle on, you see places like India and China and even Eastern Europe getting more and more lights, electrification, but still vast areas that are, as Scott Tinker likes to say, are in energy poverty. And this has a big impact on security. So the big 3 are Russia, the Middle East, and the United States. And recently, the United States was not in the top spot. Recently, the U.S. is now producing more million barrels a day equivalent, if you combine oil and gas, than Saudi Arabia or Russia. And this has a huge impact. There you can see some of the major choke points for transportation. And the way to manage the security, of course, is to produce more, changing the balance of power, and to diversify. No individual energy source is perfectly secure, but green and blue are good. And you can see that natural gas and nuclear, geothermal, wind, these are all having alternate sources is good. So now, the punchline, we've talked a lot about the basins, what we can learn from the geoscience architecture of the basins. So how do we transfer this knowledge? And so majors are in many superbasins, like Chevron, Exxon, BP are in 10 or more of the world's largest basins. So they have technical expertise that they can share through centers of excellence and other ways within their company. But for the rest of us who are in smaller companies, we need to take advantage of learning from these big basins any way that we can. And one of the great unsung contributors to this conversation are service companies. They work more basins with many clients than a lot of the major oil companies do. And this is a place, I believe, where AAPG and professional societies, by holding conferences and making publications, can help with the technology transfer, have a critical role to play. And so one of the things I initiated last year when I was president of AAPG is the Superbasin initiative for the AAPG Bulletin. And we have a pipeline of about 10 papers on the world's largest basins, the geoscience and the architecture. We are looking for more papers, and this is something I hope will be valuable. Also, in yellow, I've highlighted the first Superbasins conference and the total number of attendees, the second Superbasin conference, and the planned Superbasins conference. All in all, we've had about 11 Superbasins themed events for AAPG. We've had about 4,000 attendees, and we have interest in going forward. And we've upped the numbers to 4,000 attendees at the various conferences. And these are the speakers from the first one and the second one, real leaders in the industry, and they have contributed a lot of insights. So I'd like to end with a graph that some of you may have seen me show at my APG presidential address. It talks about the good old days, the golden age in the Permian Basin in the 1970s. And for those of us who worked the Permian Basin, we remember well the long decline. And what I like to do when I talk to students is I ask them to predict what they anticipate is going to happen here. And of course, you can use a ruler and make your prognostications. And of course, what we all know in this room happened is because of the unconventional development and optimization, there's actually a newer golden age that's even greater than the previous golden age. And that this is pretty exciting because for those who think in terms of peak oil, we're actually using technology. We're having waves of renaissance go through these old basins. And so I've talked to a lot of wildcatters, old wildcatters in my day. Some of you may be in the room. Does anybody remember this book, This Fascinating Oil Business? For a generation in the 60s and 70s, it was the book that got a lot of people interested in the energy. If I were to change the title of this book today, I would just change it to This Fascinating Energy Business. And I tell the students, for those of you who are students in the audience, that this is a golden age. We're in it. You need to be part of the energy solution. Be a lifelong learner. Technology and opportunities change quickly. You need to be flexible and be proactive in professional society. Say yes and participate. So congratulations to Dallas Geological Society, and congratulations again on the dawn of your second century. Thank you.